The moment when the Orion capsule returns to Earth is the most critical phase of the entire mission, traveling at over 19,000 miles per hour. It cuts through the atmosphere surrounded by plasma, with temperatures hotter than lava. And for several minutes, communication simply disappears. Even with all this advanced technology, the process demands absolute precision. The mission can be flawless in space. Systems can operate perfectly for days, but during re-entry, everything happens at the same time. Extreme speed, extreme heat, and almost no margin for error. That is exactly why this moment is considered the most delicate part of the entire journey. To truly understand it, you need to visualize what is actually happening. Orion does not simply fall back to Earth as many people imagine. It is returning from deep space with an enormous amount of accumulated speed. Unlike an airplane, there is no engine slowing it down and no second attempt. Everything depends on how it enters the atmosphere. This process begins long before we see any sign of fire. The capsule must align perfectly to enter what is known as the re-entry corridor, an invisible and extremely narrow path defined by precise calculations. If the angle is too steep, the air compression increases violently and the heat rises rapidly. If it is too shallow, the capsule can literally bounce off the atmosphere and be thrown back into space. Yes, like a stone skipping across water. This is not theory. This is real. Physics happening at extraordinary speed. That is why this moment is calculated with near-perfect precision. Now imagine the next stage. The capsule begins to encounter the upper layers of the atmosphere. What happens next is not simply friction. The air in front of it cannot move out of the way fast enough. It is compressed so intensely that its temperature rises dramatically. At that point, the air transforms into plasma, a superheated and electrically charged gas that completely surrounds the capsule. This is what creates that intense glow, almost like a fireball descending from the sky. But the most remarkable part is that this plasma creates an invisible barrier. Radio signals cannot pass through it, and something unusual happens. For several minutes, Orion becomes completely isolated, with no contact with Earth, no data transmission, and no external confirmation. This moment is known as a communication blackout, and even though it may sound intense, it is entirely expected. Everything is designed so the capsule can continue operating autonomously. The onboard systems remain active, guiding the spacecraft, correcting its trajectory, and keeping everything within ideal parameters. Meanwhile, outside the capsule, temperatures can exceed 5,000 degrees Fahrenheit. Enough heat to melt most known materials. This is where one of the most critical elements of the entire engineering system comes into play: the heat shield. The base of the Orion capsule is equipped with one of the most advanced systems ever built. But what makes it truly fascinating is that it does not function as a simple barrier. It does not try to resist the heat. It is designed to sacrifice itself, layer by layer. The material gradually erodes, absorbing and dissipating thermal energy. This process is known as ablation. As the outer surface slowly burns away, the interior remains protected. It is a smart strategy. Instead of fighting the heat, the capsule manages that energy, and it has to work perfectly, because everything happens within minutes. As Orion moves through the atmosphere, its speed drops dramatically, from around 20,000 miles per hour to increasingly controlled velocities. Then comes the next critical phase: the deployment of the parachutes. It does not happen all at once. There is a sequence. First, small parachutes are released. They help stabilize the capsule and reduce oscillations. Then the main parachutes deploy, large structures designed to withstand enormous forces. They open in stages, controlling the deceleration progressively. It is remarkable to realize that within just a few minutes, the capsule goes from an extreme speed to a relatively gentle descent. Now moving much slower, Orion approaches the surface, and its final destination is the ocean. usually in a pre-selected area where recovery teams are already in position with ships, helicopters, and divers, all synchronized for the exact moment of arrival. Then the impact with the water occurs, controlled and calculated. The result of that entire precise sequence, within minutes, the capsule is stabilized. Teams move in and begin the recovery process. Only at that moment can the entire mission truly be considered a success. It is striking to realize that after traveling thousands of miles through space, orbiting the moon and crossing the void, the most technical and demanding moment happens right at the end. Because returning to Earth is not simply descending, it is confronting the atmosphere at the very limits of physics. It is the transformation of speed into heat, controlled with extreme precision. Every second of this re-entry represents years of engineering, testing, simulation, and technological evolution. And when Orion begins its return, all of this unfolds in silence. There is no spectacle for those inside. Only the quiet execution of an incredibly complex process. Behind that silence lies a system operating at the very edge of what physics allows